All right, here's some basic property information that you need to know about compounds. First of all, let me remind you that previously you learned about elements. Those are individual small atomic particles. Individual atoms are elements. If individual atoms pair up, combine, what we call bond together to form a larger multi-atom particle, we call that a compound. So again, elements combine to form compounds. Specifically, this information is going to be about molecular compounds. Compounds, again, that we classify as molecular. Here are the properties that molecular compounds have. And you will be doing a lab based on this later, so writing down these properties will be very helpful in analyzing the results of that lab. First of all, molecular compounds have very low melting and boiling points. That means they will melt or boil at fairly low temperatures. They do not have to get very warm at all for that to happen. They do not conduct electricity. That means that negative charges will not flow through them. And in the lab, we're going to be testing that with a conductivity probe. May or may not conduct electricity also when dissolved. So no matter what, really what you need to know is molecular compounds do not conduct electricity. Here's how we describe molecular compounds. They exist as individual molecules. So when we describe a molecule, we are specifically describing a molecular compound. They have a definite composition. They are held together by relatively weak attractions proportional to the size of the molecule. I'm going to show you a picture in a minute. This will make a little more sense. So here's an example of a very simple molecule, AB. An A atom bonded to a B atom to create a molecule. You see this term binary? Seems complicated, but it's actually pretty simple, meaning two. So it's a two-atom compound, one of A, one of B. And the picture that you're going to see, A happens to be more attracted to B than the B is to the other B's. So here's a picture of that and a description. The red side of each of these molecules is the A atom, and the light-colored side is the B. So all together, this is a molecule, an AB compound. There's a whole bunch of molecules all lined up in this kind of symbolic picture. So again, notice, anywhere there's a molecule, A is always next to a B, but this particular A is way more attracted to this B than this B, and so together they form a compound bonded together, a molecule. Notice, each molecule makes a distinct larger particle than just an A or just a B. This is going to be different than the ionic ones that you see later. Here's a couple of laws that we apply to molecular compounds. One is the law of definite proportions. And the thing I want to point out, which you can also read everything else here, is this formula H2O. This law of definite proportions means that for water, there are always 2 hydrogens for every 1 oxygen. And this is a symbolic shortcut method for us to represent the composition of water. H is the symbol for hydrogen from the periodic table. O is the symbol for oxygen. And these little numbers that follow these symbols tell us the proportion that they are found in this entire compound, H2O. So for this particular one, it means there are 2 H's for every 1 O. There's no 1 behind the O, and that's because it's understood that if there's no number there, that it is a 1. So this is a 2-to-1 ratio. This is always the way that water exists. It is a fixed proportion for this compound. Again, your example here says there's never 3 H's for every 1 O, only 2-to-1. Another one is the law of multiple proportions. And here's some examples of this. Again, we get down to this example with CO2. This is the chemical formula for carbon dioxide. Carbon and oxygen in a 1-to-2 ratio. And the thing that this law talks about is that if we compare the mass of O, oxygen, and the mass of carbon, it exists in a ratio that looks like this. roughly twice as much oxygen than carbon, hence the formula CO2. Carbon monoxide is a different carbon-oxygen compound. It exists in just a 1-to-1 ratio, so that formula is CO. You're going to do some practice with binary molecular compounds. Again, binary means two. So two elements bonded together to form a compound. These are composed of nonmetals. And if you look at your periodic table, the elements on the right side of the periodic table, the very right side, are where you find the nonmetals. To name them, we have to use prefixes in their name to name binary molecular compounds. So I'm going to scroll through these rules. Oops. And go ahead and pause it here, and I would write these down, what you need to write down. We're going to use a prefix in a name for the first element if there's more than one of them in that element. And we're not going to change the ending of the first name. The second name, the last name of the compound, follows the second element's name, which will always have a prefix, and the ending will be changed to IDE. Again, I'm going to show you some examples, so this will make a lot more sense. Here are the prefixes. This is what you need to do. You need to pause right now, write all of these down on a reference sheet, maybe your significant digit reference sheet that you already have, or the back of your periodic table, because I don't expect you to memorize them, just use them. All right, so here's how these rules go. We're going to name a couple of compounds. Here's the first compound, CCl4. Get my drawing tools here. Okay, I'm going to try really hard to write with my mouse. Okay, these two elements are carbon and chlorine. The first element, carbon, there's only one, and so we're not going to put a prefix on that. So its name, first name, is carbon. The second or last name of this compound then has to come from chlorine because Cl is the element chlorine. There are 4 of them. So we're going to use the prefix then tetra. If you look at the previous slide, the prefix for 4 is tetra. Then chlorine, instead of saying chlorine, the second element in the name always ends with IDE, so it's going to be chloride. Carbon tetrachloride is the name for this element. Or sorry, not element. Oh, please scratch that. Compound. Okay, second compound, P2O5. This time our first element does have a number, so we need to put a prefix there to specify that there are 2 of them, and that would be di. The element is phosphorus, so this name is diphosphorus. Oh, this is really hard. I am sorry. Diphosphorus is what that says. Then our second element is oxygen with a 5, and so we need to put a prefix in front of that, which is penta. And since penta, the A in penta is going to be right next to the O in the oxide, usually we get rid of the double vowel, so probably you would see this as pentoxide. And again, IDE because it's the second name. Okay, let's see what's next. Maybe. Okay, now we're going to give formulas for these names. We're going to go the other way. So our first name in this one is dinitrogen. So nitrogen is N, and the di prefix, again, from your previous list, tells us that that is a 2. Monoxide. Well, oxide comes from the element oxygen. Mon means 1, and so I'm not going to put a prefix here because it means 1. So this is a 2 nitrogen, 1 oxygen compound. Oxygen difluoride. O is the symbol for oxygen. That's my first element in this compound. F is the symbol for fluorine, which is where this name comes from, and di means there are 2 of them. Okay, I think this is the last, no, not the last practice. Let's name these also. And if it's okay, I'm not going to try to write these. That'll save some time. If you aren't sure how to write them, please give your best and show me after you do this, and I'll check them for you. Okay, this name. Notice, this is kind of interesting actually, that these are all nitrogen-oxygen compounds. So the thing about molecular compounds, they can exist in very many different ratios. So the first one, this would be dinitrogen monoxide. Dinitrogen monoxide. Next one, nitrogen dioxide. Next one, dinitrogen pentaoxide. Next one, nitrogen monoxide. And then the last one is dinitrogen tetraoxide. Okay, and then last thing to do is to practice writing some formulas. Here's what I would do. I would pause this, try to write them, and then check your answers. Here they are. Cl2O. This one, chlorine dioxide, ClO2. Chlorine heptoxide, ClO7, I believe. ClF3 for chlorine trifluoride. Okay, hopefully you did well. Please see me if you have any questions. Following this video is a digital copy actually of practice with all of these ideas, and there's a paper copy in the practice folder for you to do. Highly recommended. This is very important information you're going to use for the rest of the trimester. Have a great day.